Alright, in this video we're looking at finding the shortest distance from a point to a line, and there's sort of a three-step process you can do to find that. But let's draw a picture of this first so that you can see sort of what I mean by this shortest distance. This line that I'm describing in the question starts at that point there, and every time it goes across 3 it goes down 1. So there's a line that looks something like this, so it just keeps going back up and left, etc, etc. And then you would connect up these dots to make yourself a lovely line. Just like that. So that's the line described in this question. Now let's look at the actual point. It's 5, minus 1. 1, 2, 3, 4, 5, minus 1 here. So this is the point that we've called P, and this is our line. Let's just call it L. Okay, so if we want the shortest distance from this point to a line, you can probably imagine like, well, okay, if I took the distance from the point there, that's probably not the shortest distance, right? Like we took a pretty long way to get to the line. You might want to go straight from the point directly across to the line, and then whatever distance that is there would be the shortest distance. And if you think about it, you sort of have to make a right angle, because if you don't, then if you haven't made a right angle, then you haven't taken the most direct path to the line. You can see I've basically drawn it. It's 90 degrees there. So what we do with this is we sort of call this point here on the line, we call this point R. And if we think about it, if I think about the vector P dot R, so that's this blue vector here, this should be perpendicular to the direction vector of the line. Let's call that B. Now we actually know what B is. B is 3, minus 1. So then whatever vector it is, PR should be perpendicular to that. Now we can actually work out what PR is, because if we think about a point on the line R, that's just going to look like 1 plus 3t and 2 take t. So if we want to go PR, it's going to be the coordinates of R, so 1 plus 3t, and then we're going to take away the coordinates of P. So take away the coordinates of P. P was the point 5 minus 1. So let's be doing that. So this is going to be 1 take 5 is minus 4 plus 3t. And then 2 take t, take away minus 1 is going to be 3 take t. So this here is the vector P dot R. And we already have the vector B, which was supposed to be the direction vector of the line 3 minus 1. And then hopefully PR dotted with B should give us 0 if it's perpendicular. Now, basically what I'm doing here is I'm going through these 3 steps. So we've constructed that vector there, PR, and then we're going to find the optimal t-value by solving PR.b equals 0. We're up to step 2 now, essentially. So let's think about what PR.b is. We're basically going to dot this vector here and this vector here together. So we're going to get 3 times minus 4 plus 3t from the x coordinates, and then we're going to get minus 1, 3 take t from the y coordinates. And this should all equal 0. So that gives us minus 12 plus 9t, take away 3 plus t equals 0. So 0 equals minus 15 plus 10t. Therefore, 10t equals 15. Therefore, t equals 15 over 10, or in other words, t is just 1.5. There we go. Okay, so that's really good. Now that we know what t is, there's a couple things we can do with that t value. The first really interesting thing we can do is we can actually find the coordinates of this point R by plugging in t equals 1.5 to this equation. So here, if we had t equals 1.5, actually not from that equation, but from this equation here, t equals 1.5 would give us the R value. So that would give us 1 plus 3 lots of 1.5, so it would give us 5.5. And then 2 take away 1.5 would give us 0.5. This is this point we've been calling R. And if I plot it on there, 5.5 and 0.5, that point would belong about there. And you can see that's pretty much the same as what I drew as the R value. So it all works out. But that's not what they were asking. They're actually asking for the distance. So what's that blue distance there? Well, it's literally just the length of the PR vector. So let's work that out. All right, so PR, if we sub in t equals 1.5 to this, let's see what we get. So I get minus 4 plus 3 times 1.5, and then I'm going to get 3 take away 1.5. So that's going to give me minus 4 plus 4.5. and then 3 take 1.5, which is going to give me 0.5, 1.5. So this is our PR vector, where t equals 1.5, just there. Now the distance is literally the length of PR. So that distance there is going to be square root of 0.5 squared plus 1.5 squared. And that's something we can just work out on a calculator. So 0.5 squared plus 1.5 squared is 2.5. So we've got root 2.5. If we work out what that is, let's see, square root of answer. So it's about 1.581 units. Now let's go back to our diagram to make sure this actually makes sense. If we sort of zoom in on that blue line, you can see, I would probably agree that distance there is about 1.5 long. That blue line looks to be about 1.5 squares long. So it seems that we've done this correctly.